All right, we are switching gears a little bit for the next few lessons. We're going to be graphing, and we're graphing in the unit we're in, which is rational. So first time probably ever in your life you're going to graph. You can kind of focus right here on this one, and you can see we're going to be graphing rational functions. So where the x is in the denominator. I don't think you've ever done that before. And there's lots of ways we can handle this. To start, we could sit here and just plot points, get an idea what's happening just by, picking some x values, whatever ones we want, and then plugging them in, get the y values. We can do that. There is a focus. There are some questions. You're not just graphing. You have to answer these questions. It says identify the vertical asymptotes, x-intercepts, horizontal asymptote domain, range. That's it. And then, of course, if you have all that, you probably have a sketch of the graph. So we're going to need to kind of go a little slow on the first one here, and we'll get us started. These are curvy things. They're not lines or anything like that. They're going to be curvy. And I think the first thing we need to do is talk about asymptotes. We need to talk about what an asymptote is. An asymptote is a line on a graph where the graph never hits but gets closer and closer to. And we'll talk about that some more, but that's going to come in. In other words, like for a vertical asymptote, we need to figure out what x values can never happen in this problem. That's really that's all a vertical asymptote boils down to. And we talked about that before. We talked about how in this case, x, if you look at this problem here, this will be our first thing we think about. X can't be 0. If we look ahead here to another one, x can't be 2. And so the graph cannot exist at those values. Before we were just saying, okay, x can't equal 0. Like back to this problem, x can't equal 0. We just say it. But now we're trying to draw a picture of this situation. And so here's our first thing we need to do. Here it comes. We need to draw a dotted line right through here. And what that's saying is that since x can't equal 0, then this graph can never go through that line, touch that line, anything. So this is representing that idea. And the more we do this, the more you'll understand what's happening here. The second thing. So vertical asymptotes are, you draw a vertical line where all the values that x cannot equal. In this case, it's just x can't equal 0. When the denominator equals 0, that's always bad. It creates a vertical asymptote in a graph. X-intercepts. X-intercepts are your zeros. Okay? X-intercepts are the same thing as zeros. It's where this graph is going to cross the x-axis. And so we're wondering when y equals 0. So we're going to set for x-intercepts, we're going to set the whole function equal to 0. So we're going to do a little algebra here. And this is probably where I'll zoom in a little bit for a little bit here. Oops, that didn't work. Let's get rid of that. Can we get rid of that? Uh-oh. Maybe I can erase it. Oh, there we go. All right. So let's zoom in, just so we can see the work a little better. So what we're doing now is x-intercepts. So for x-intercepts, we're going to take the function and set it equal to 0. So 1 over x plus 1 equals 0. 1 over x equals negative 1. And why don't we cross multiply here? Think of it like that. So we're going to put negative x equals 1. That's me just going like this and that. Okay. And then we can see that x equals negative 1. So negative 1 is an x-intercept. There's a point on this graph, negative 1, comma 0. Because when I plugged a 0 in for the y value, or the f of x, y, same thing. So when y is 0, we solve for x and we got negative 1. So there's a point on the graph right here. And so that is our only x-intercept. The next thing, you can zoom out if you want for a second here, is horizontal asymptote. For today, so for the horizontal asymptote, that's always going to be affected by, let me show you here, this number. Because what's going to happen here, and we've learned this from other graphs, is we're taking a normal rational graph and we're going to shift it up. So what's going to happen is, and this will all come together after we finish this first one, but what's going to happen here is we're going to draw a horizontal dotted line at whatever this value is right here, up 1. So we go like this, and plus 1, so we're going up 1. That's another restriction on the graph. Let's zoom in for a second again. You can see what's happening here. And you can see I'll give you a little sneak preview. What's going to happen is we're going to have some curves. We've created 4 regions. By having a vertical asymptote, we have a horizontal asymptote, and we created these 4 basic regions here. And the graph's going to be in either a couple of them this way, maybe a couple this way, and we'll know that just by plotting points and things too. But for now, your vertical asymptote is whatever makes the denominator 0, and your horizontal asymptote normally would just be the y-axis, but this shifts it up. So this becomes the new thing right here. Okay, we're just about done. I mean, that's really it. Today's focus is just to get the vertical asymptote, horizontal asymptote, and then we got an x-intercept right here, just following the directions. And then they want domain range, which we already know about those. We're trying to think about what values we're allowed to plug in for x and what values spit out for the y value. And then that should, we'll plot a couple points and we'll have a sketch of the graph. So domain. So when you're doing domain, you have to think to yourself, what am I allowed to plug in? If I was going to make a table or something, let's say we're going to make a table here for this. And in that table, we're thinking to ourselves, what values would I be allowed to plug in for x? That's your domain. It's all the values you're allowed to put in for x. And in this case, it's very related to that vertical asymptote. You can plug in whatever numbers you want right here, except 0. So your domain for this problem, let's label it D for domain, would be, I've done this for a little while, huh? Negative infinity to 0, and then start it back up again, 0 to infinity. That's a 0 right there. And then our range, which is the other question on here, the range, what we have to do here is think about what are the values that we can't get to come back out. What y values can't we get? And that's very related to the horizontal asymptote. Because what's going on here, you're not allowed to plug a 0 in here for x. That was part of the not in the domain. And so there's really no way to make this piece of the puzzle here be 0 because it's undefined. There's no way for this to be a 0. It would have to be x in the numerator to be able to plug a 0 in there and get 0. So if this can't be 0, 0 but you can't get plus 1 means you can't really get 1 for this whole thing. Because if this can't be 0, how could the answer be 1? Because the only way to get 1 would be plus 1. You'd need 0 here, and you can't get that. So the range is everything except 1. You also get that by looking at the horizontal asymptote. Okay, it is at 1, and so the graph is not going to exist at that spot. So the range is going to be negative infinity to 1. And then 1 to infinity. Of course, all both of those mean is, another way to say it is everything, all real numbers except 1, and all real numbers except 0. This is just a fancy way to say it. All right, Last, all we really need to do now is plot points. So we're going to plot some points just to see. It says sketch the graph is the last part of the direction. So we actually need a graph here. So what we'll do there is we will make a T-chart. And we'll just pick some values. You just need a few. You just want to see what's going on here. We already know 1 point on the graph is at -1, 0 right here. And why don't we do -2, maybe we'll do -3, and we'll do 1, 2, 3. We'll see how that goes. We're going to get some fractions in these. This is a unit on fractions, so be ready to deal with fractions. So we're going to go, let's go -2. Let's start with -2, 1, and 2. Remember, we can't plug a 0 in, so we're not going to do that. And if I were to plug a -2 in here, this is the part that some of you are going to get hung up on. If I put -2 right here, I get -1/2. -2 there, -1/2. And -1/2 plus 1 is a half. So this becomes half. And then putting a 1 in there is real easy. Just 1, you get 1 over 1, which is 1, and 1 plus 1 is 2. So there's a 2. And then this one, if you put a 2 in there, you get 1/2 plus 1, which is 1.5. But we don't usually write 1.5. We're going to write 3 over 2. Well, let's just start with that. Let's just see what happens here. So we have -2, comma, 1/2. So -2, 1/2 is right in here somewhere. And then 1, 2 is right there. And then 2, 1.5, which would be right in here. And if you look at it, you can see that this here and this here, they're kind of mirror images of each other diagonally. And I mean, we could stop there. I'll just tell you right now, here's what's happening to this graph. It's going to go like this. Like that. Remember, asymptotes mean that it's getting closer and closer to that line, but it's never going to touch that line. And you can see that. Let's plug in just for fun here, just so you can see what's going on. What if I put, let's say, a 10 in there? Okay. If I were to put a 10 into the function, put a 10 right here, we get 1/10 plus 1, which is 1 and 1/10, which is just, here's 1. So if I go over to 10 for x, it's going to be just barely above the 1. If I were to put 100 in there, 1,000,000, whatever, 100, it's just going to be, it's always plus 1, so it's going to be 1 over 100, which is a tiny, tiny number, plus 1. So it's always 1 and a little bit more. So even if you went all the way over here, you know, to 100 or whatever, which is not even, it's way off this screen, it would still be just a little bit above 1. And that's why this graph keeps going closer and closer, but never hitting that 1. Same thing would occur going this way, this way, and this way. It's getting closer and closer. This one's just going to be the negative versions of what we're talking about. And then down here, since you can't plug in 0, you can only plug in numbers closer and closer to 0. You're just never going to touch that asymptote. All right, let's do this again a little faster. So let me scoot over to another one here. Well, let's go a little faster on this one. All right, step 1, vertical asymptote. Vertical asymptote is always when, I'll actually write it out for you. So vertical asymptote is when the denominator, you set the denominator equal to 0. I mean, obviously in this problem it's going to be 2. Okay, x equals 2 is a vertical line. It's going to be at 2. So we draw this vertical line right here. Dotted line. It's not like it's really part of the graph. It's a guideline. It's a line showing you what something's getting closer and closer to. X-intercepts. X-intercepts, you set you set the whole function equal to 0. And solve. So you get 2 over x minus 2 equals negative 2. And then you're going to cross multiply. So you're going to have negative 2x minus 2 equals 2. You get negative 2x plus 4 equals 2. Negative 2x equals negative 2. Having a little trouble with the pen today. And so it's x equals 1. So we now have a spot at 1, 0. Remember, we plugged a 0 in for the y value and then solved for x. So it's the point we just found was 1, 0. And so that's right here. Okay, next thing we need to find is the horizontal asymptote. It's pretty simple for today. It's just going to be this value. You're just going to go up 2, and you'll draw a dotted line there. So it's going to go like this. Domain. Domain is everything except 2. Domain is all the x values you're allowed to plug into a function. I'll even say it different this time. I'll just say all reals x not equal to 2. Just a fast way to write it. And the range is, this is where you got to think again. This is a little trickier. Well, it's really not that tricky because it's always going to be the horizontal asymptote value. It's going to be 2 for that one also. But the reason, one more time, is because since you can't create a 0 here, because there's no, if you try to put a 2 in here, that's the closest you'll ever get to creating 0, but it's in the denominator, which is undefined. So there's no way for this to be 0, and since this can't be 0, then 0 plus 2 can never happen, so therefore 2 can't happen as the answer to this problem. So it's actually the same exact range, only it's for the y values. And then to do the sketch, just pick a few points. You want to pick a couple points to one side of the vertical asymptote, pick a couple points to the other side. So in this case, we already have 1. Let's do 0. We're allowed to plug a 0 in this time. And let's do 3 and 4. The question is going to be, where do I do all that work? How about we go, I think we can scoot down a little bit. Shrink it up. Scoot her down a little bit. And here we go. So we have, we're going to plug in, let's go negative 1, 0, 3, 4. If you're wondering once again why I picked those numbers, negative 1, I'm just starting over here. So negative 1 is going to be, I'm going to check what the y value I get for negative 1. Then I went to the next one. I already have this one. I can't put in this one, so I went to 3 and 4 as the next two, just to get some on each side of this line. And we're going to want to look at the function at the same time. So the function, so I'm going to put a negative 1 in here. Right here. Okay, so if you want me to do a little work on that one, I can do a little work. It's going to be 2 over negative 1 minus 2 plus 2, which is 2 over negative 3 plus 2. Negative 2/3 plus 2 is 1 1/3, or 4/3. You can get that however you want, but that's what it is. Okay, so that point at negative 1 4/3 would be something like negative 1, and then 1 1/3 is going to be right about in here somewhere. Right here. Looks like about 1 1/3, close enough. Okay. Then let's go back to our table here. Let's do 0. So 0 is a lot easier because 0, if you put a 0 in here, you get -2 right there. And 2 divided by -2 is -1, and -1 plus 2 is 1. So we now have a point on this graph at 0, 1. And now you can kind of see where that graph's headed. This one's headed to something like this. That's one side. And then we need a couple points on the other side. So we're going to put a 3 in there, which is an easy one. If you put a 3, if you took this number, plugged it in here, it's 1. 3 minus 2 is 1. 2 divided by 1 is 2. 2 plus 2, 4. So this number is a 4. And then let's do 4. 4 is not too bad either. So this only one that was a little annoying was the fraction right here. But if you pick your numbers smart, you don't have too many fractions to deal with. So 4 minus 2, here's 4, it's going up here. 4 minus 2 is 2. 2 divided by 2 is 1, and 1 plus 2 is 3. So this is a 3. And then let's zoom back. We're going to do 3, 4, and 4, 3. Let's see. Let's just zoom in. 3, 4, and 4, 3. 3, 4, 4, 3. And that's enough. I mean, as long as you know, you're seeing these graphs, so you know they're curves, and you know they're going to have to get closer to the asymptotes. So, once you have a couple of points, you know what region it's in, and you just kind of make your graph. You don't need to get a crazy amount of points here. That becomes not fun. So once again, it looks like, and this is going to be the case, I think, for every graph today, that they're in diagonal areas. Like you might have one here, or it could be one here and one here. But you're going to have two pieces to this graph, and they're almost trying to get to the asymptotes, but they never quite get there. And so all you're doing is getting the asymptotes drawn in, plot a couple points in each area so you can figure out what's going on, and just connect the dots. I'm going to do one more. This one's it's nothing different. In fact, it's a little easier. The only thing different was I put a negative in the front here. I didn't put a number on the outside, though. There's no plus or anything. We need to talk about that. So here we go. Let's go quick. I'm going to race through this one. Vertical asymptote. Okay, you can see the vertical asymptote is the number you can't plug in for x. In this case, it's 1. You can't put a 1 in there. So vertical asymptote is x equals 1. So I'm going to plot a dotted line, or a vertical line, at 1. There it is. Okay, X-intercepts. Probably the most math you have to do is on that. So you're going to take the function, this is always true, take the function, the whole thing, -2 over x minus 1, and set it equal to 0. Now in this case, you're just going to straight up cross multiply right now. So it's going to be like 0 over 1 basically. So you have 0 equals -2. And that doesn't make a lot of sense, which is good. It shouldn't make a lot of sense because, there's no x left. When you cross multiply here, 0 times anything is just 0, and you're left with an equation that you can't even solve. In fact, it's just an untrue statement. It doesn't make sense. Whenever something like that happens, it means there was no solution to this equation right here. which means there is no x-intercepts. But you would have figured that out if you went to the third thing, which was to find the horizontal asymptotes. Remember, in this case, there's no adding a number here, which is where we got that's how we moved our horizontal asymptote up and down. We had a +2 here. I think we had a +1. This one, it's just 0. So our horizontal asymptote is right here. Trying to let you kind of see it there. Whenever it's on the axis, it's harder to see it, but you can see I'm drawing some dotted lines there. I could even draw a different color for you so you can see it. So if that's a place where the graph can't get to, then how could it cross the x-axis? So how could it have an x-intercept? And so all that kind of comes together that this doesn't make sense when you try to solve it because it doesn't have any x-intercepts. So when you're answering that question, x-intercept, none. Horizontal asymptote, y equals 0. Domain. Domain is going to be everything except 1. So you can say all reals, but not 1. It's kind of the fast way to write it. Range is going to be everything except you can't ever get 0 because your horizontal asymptote is at y equals 0. And then the sketch. The sketch, we just plot a few points and see what's going on. Right now in this problem we have no points plotted. We have no points plotted because we don't have an x-intercept. The last couple problems I had a little head start. This time I don't. So let's go -1, 0, and then 2 and 3. That's good enough for me. Notice I skipped over 1 because I can't put a 1 in there. I'm not allowed to plug 1 into this function, period, because it would give me a denominator of 0. All right, let's see if they come out okay. I think the first one's okay. As far as no fractions go, you have a -1. If you put a -1 in here, you get -1 minus 1, which is -2. 2 divided by -2 is -1, and then it's going to change to positive because of the negative in the front. So it's +1. You can do all this. If you want to go off to the side, you can pause it, do some math. I recommend it. I just don't have the space for it, and it's just basic arithmetic. Next one, we're going to put a 0 in there. If you put a 0 in here, you get -1. So 2 divided by -1 is -2, but then you change the sign because of this negative, so it's +2. Next one, notice I'm picking nice numbers, really simple. The numbers are real small. This shouldn't be that crazy. 2 minus 1 is 1. 2 divided by 1 is 2, but then it's negative. So -2. And then 3 minus 1 is 2. 2 divided by 2 is 1, but it's negative. And now we're going to plot these points. -1, 1. It's right about there. 0, 2. It's right here. 2, -2. Right here. And 3, -1. And we're in the same ballpark as we were before. Everything's about the same. You connect the dots this way, something like this, and then come over here, do the same thing. One thing you'll want to notice is the first two graphs, the graphs were here and here. So they were in the upper right and the bottom left. Now they're in the upper left, bottom right. And that's all just because of that. That negative in the front swaps these. You know, it's kind of like a flip that we've seen in other graphs. We'll do some more in class. The video's getting a little long. I had a fourth one, but I think we can shut it down right here. It's all kind of the same. If you need to pause, if you need to see where I'm getting these values, please make sure you're taking the time to watch the video to learn how to graph rational functions, not just to take notes. Got it? Good. All right, I will see you soon. Work hard. Be nice.